Okay, so here's 14 out of 90, and here is 1/6. I'm getting pretty close. Definitely improved from when I did it one time and I never got a 4. If I had done one trial and assumed that was true about forever, I would be like, guess nobody ever gets a 4 when they roll a dice. So the more times you do it, the more accurate it is. And this is not a joke. Everybody realizes that it's theoretically possible, right, to get like all 4s, right? Extremely unlikely. It won't happen, except for like almost never. But literally, if we did this 1,000 times and started counting how many it would be, it would start to get almost exactly at 1/6. The more and more and more you do. So the bigger your sample size ends up, the more the theoretical probability narrows in into exactly what it needs to be. Range of probabilities. The lowest a probability can be is 0, and the highest a probability can be is 1. Same thing if you do percentages, it'd be 0% to 100%. You cannot give more than 100%, even in sports. Can't give 110%. You could give 110% of yesterday's effort, which means you gave yesterday's effort plus another 10%. But if a coach says to you, just give it 110%, they're asking you to die on the court and then do something. Okay, so you'd have to come back to life and then also dribble the basketball like a tenth of the way across the court and die again, if that's what they're asking for. So no way to do 110% unless it's comparative to something else. The complement of an event is 1 minus the opposite. So if I said, what's the probability of not rolling a 4? Well, a 4 is 1/6, so not rolling a 4 would be 1 minus 1/6, which is 5/6 probabilities left. So a complement is considered figuring out the opposite probability. All right, what is the probability of not getting 2 numbers that add up to 7 when rolling 2 dice? All right, when you're rolling 2 dice, how many choices are there? Justin, do you happen to remember how many choices there are when you're rolling 2 dice?
12.
Close, multiply. 36. Okay, so there's 36 choices when you're rolling 2 dice. 6 times 6, everybody okay with that so far? All right, what numbers add up to 7? 5 and 2, or a 2 and a 5. What else?
6 and 1, or a 1 and a 6.
6 and 1 and a 1 and a 6.
7, 0.
Not on a dice.
Yeah.
3, 4, 4, 3. So that's 6 out of 36 choices give you a sum of 7. So how many don't give you a sum of 7?
28 out of 36. Or 30 out of 36.
30 out of 36. Otherwise known as what? 5, 6? Conditional probability is the probability something occurs given that something else already occurred. All right, so what this means is find the probability of A, or the probability of B, given that A already happened. Okay. For example, example 6. 2 cards are selected in sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king. Assume that the king was not replaced. How are you with card decks, Georgia? Do you know how many cards are in a deck?
52.
Do you know how many of each suit?
4.
4 suits. How many in each suit?
Ace 9. Kings and queens.
And jacks and tens
Oh, yeah.
and ace. Yep.
Yep.
Okay.
All of them.
13. 13 of each. So, what are the chances that, imagine I take a king, I'm doing a card trick, and I say, pick a card, any card, and you pick a king, and I take that king, and I throw it across the room, and I say, okay, pick a card. And what are the chances that you pick a queen now? How many queens are in the deck?
4.
Out of how many cards are in the deck? No, I threw that one across the room.
51.
51. That's the conditional part about it, is that I took away one of the cards from the deck. That's what makes it a given kind of problem, because I threw one away. If we're talking about a kid's IQ, this one is a good one for using colors if you want to. Anybody want a highlighter? A highlighter? No, you're not going to use one on your tablet. Yeah, use it on your tablet. You'll always have highlighted that part of your tablet. Hope it keeps working that way. All right. Table below shows the result of a study in which researchers examined a child's IQ in the presence of a specific gene in the child. Find the probability that a child has an IQ given that the child has the gene. So we're only going to look at the kids who have the gene. That's all we care about. So how many kids that have the gene have a high IQ? 33 out of how many? 72, yeah. So the given part tells you kind of what the total is going to be on the bottom. Try example 8 with your team, please.
Basically. Basically, after you're good.
Okay, so if it was given that the child has a normal IQ, you should have just been looking at this one. So it should have been